1, 2, 3. Can you wear this mic?
So let's.
Yeah. Still working. Yes, set up. Wait, yeah. Try it.
This in the pocket.
Do you want to give me a sound check?
Hello? Check, check. Can you hear me in the back? I guess not. Hi. Am I loud enough? Maybe some. Okay.
So this is your 1 minute warning. If you're loitering outside, come in. Otherwise you'll miss the first bit. Put out the joint and come inside. You, yes you. You know who you are. Right, I think we'll give it 30 seconds here.
Yeah. That's cool.
While you go to... Do you need sound for the slide demonstration?
No, I don't. I can do without.
Okay.
What's going on?
Right, so do you want to make that full screen?
Yeah, it's on the wrong screen now, so that's what I was trying to get.
Windows fail. Actually, PowerPoint fail.
I will just...
We could try and make PowerPoint karaoke out of this. Hands up here, everyone who's kind of like well into their web apps.
I will just do some cloning, I guess. See where we are.
Windows is a great way to learn a foreign language, you know. I know the words for cancel and okay in half a dozen different languages now. Rolling hills, blue sky.
Fonts.
Kind of looks like outside.
Let's see what it's going to do now. So that's not what I'm looking for.
Victory for Zim?
No. I want to do some cloning, but...
Oh, okay. Well, in best con tradition, I think it's going to have to. We can be a minute late while you mess around with this.
Yeah, well, we're just going to do it this way, so I'm sure that everything pops up there.
Okay, excellent, excellent. So, on a very hot and sweaty afternoon, we have for your pleasure and education, Jacob van. Now, this sounds a bit like towel, but...
It does. Jacco van Tuil.
Jacco van Tuil. So can I have a big round of applause, please, for Jacco? Take it away.
Thank you. Nice to have you all here. Because a lot of big companies, even security companies and big financial institutions, still fail to fix even the simplest of programming mistakes in their software, I think it's wise to, again, give some more information about these old and well-known vulnerabilities that are still found a lot in web applications. And that won't be stopped by a regular antivirus or firewall. So, as they already told, I'm Jacco, and for the next 45 minutes I'll be giving you a presentation about the insecurity of web applications. I will be speaking about some common vulnerabilities that I've come across anno 2009, and I will discuss how to exploit them and what the impact is of these common vulnerabilities. I've set up two server types to demonstrate some of the security leaks that are very common in web applications. One of them is a Debian-based LAMP, and the other one is a Windows-based IIS environment. To show you that it's not one particular operating system or one particular web server that has these vulnerabilities, or they don't have the vulnerabilities. The programmers who code the web applications in the framework often don't do data verification, and that can lead to security compromise. Okay. So, one-on-one threats. I'm going to talk about some common vulnerabilities. That was also stated I was going to tell something about a zero-day ActiveX exploit, drive-by download, but due to pressure of the vendor, I decided not to make it public today. So, due to the fact I have some less content than I was supposed to have, but I will try to fill it up with some more examples. I think we'll have more than enough information for the next 45 minutes. Okay, first it's good to know what is a web application. What happens when you enter a URL at your client, the Internet Explorer, Firefox, or something else. It sends an HTTP request to the web server, and on the web server, the server-side code starts running. The server-side code will get the data from the storage to produce the HTML response, and will send it back to the client. The client will load the HTTP response into the DOM, the document object model, and then renders it to your Explorer. Okay, the common vulnerabilities. We'll start with XSS. XSS stands for cross-site scripting, and is one of the most common vulnerabilities found these days. About 60% of all the vulnerabilities found are XSS related. Oh, I see. I also have a cross-site scripting in my page. Okay, there's some different types of cross-site scripting. We have the persistent, the non-persistent, the DOM-based. I'm going to talk about some payloads that can do some interesting things. I'm going to point you to some tools and show you some of how they work. I'm going to discuss some filter evasion techniques, especially for XSS. Okay, persistent and non-persistent cross-site scripting are also called stored or reflective cross-site scripting. First, we're going to talk about the non-persistent XSS vulnerabilities. They are often found in search forums of logins, or the script name, or any other variable that will be echoed directly in the response page. And it allows users to inject malicious code that runs on the client. So you can add JavaScript, HTML, or embedded objects, or in Internet Explorer you could try to embed VB script. Okay, I have some small example to make more clear what the non-persistent cross-site scripting what a non-persistent cross-site scripting is for. And to show you, I have a search page where you can enter a search string, and he will go and look through the database. I'll just type something. I will increase size a bit to make it more clear, I think. Is it readable from the back? No, eh? I need to figure out what my numlock is. The numlock. Okay. So the item with the name was not found, and as you can see, one of the parameters I enter in this forum is directly reflected in the response, and so is a possible victim for cross-site scripting. To check if cross-site scripting is possible, I have this very classical cross-site scripting example. Yeah, and yeah, okay, thanks. And if the attack works out well, it will pop up an alert window, and that will show the number 1 in this case. And you can see that the JavaScript I've added in the search box was executed on the client machine. In this case, it's reflective, so it's the same machine as who injected it into the request parameters. Okay. Back to the presentation. Okay. And the same goes for logging forums, where sometimes the name after a false login is reflected in the result page, and that could lead to cross-site scripting. A non-persistent, also called reflective. And as you can see on the slide, it's not only a problem for get or post variables, but it also it can also exist in other variables as host name, script name, or other things that are included in the HTTP request. Now we're going to talk about non-persistent cross-site scripting that is a bit more dangerous than the other ones. It can be used in a link on a website. Oh, we're still at non-persistent, sorry. I was one sheet ahead. Non-persistence can be used to make a malicious link on the website to lure someone into opening the link and so executing the client-side script. It can be used for spear phishing, and I have a little example of that. I believe, I hope the link is still up. I had an example of that, but too bad, too bad. But the cross-site scripting link can be added to the email, and when someone clicks on the link, he will be redirected to what he thinks is a valid site, but in that site the attacker could have injected some malicious code, some fake login screens or other things. And it can also be used in other places where you can use HTML links, like in this presentation. And you'll see a JavaScript executed that was never on the real website. It's injected in the URL. As you can see above here, it's a bit small. Let's see if I adjust a little bit. So it gets a bit more clear. Is it readable in the back now? This is still too small. Okay. So as you can see, I've appended the malicious JavaScript to the end of the URL that I used in this presentation. And while the attacker of the viewer thinks this is a perfect legitimate site, the attacker could have given it any content you wanted. By changing the content of the document body. I'm still missing out something. Yeah, whatever. So this is not the worst variant of the cross-site scripting vulnerabilities. We're going to have a look at the persistent cross-site scripting vulnerabilities right now. And they are more severe because you don't need to lure anyone into opening an URL or something. You can just inject it into a forum, a guest book, or anywhere else where user input is stored on the data store, to later to be reflected in the website. I'll give an example of that. Here I have a guest book. There's already one message for me, and new visitors can add a message, and the attacker would add his malicious script. To the page. And you see, again, it was a successful attack. It did cause an SQL error because of unsanitized user input. And as you can see, an SQL injection flaw is also most of the times can also be used for cross-site scripting. Okay. So, and now every time somebody visits the guest book, oh, it's not stored. Bad example. I'm gonna get something. I'm going to do it quoteless to avoid the SQL injection error. So I'm going to do alert 1, 2, 3. Post. And now it was, I think, successfully added. And other visitors of the guest book will have the JavaScript executed on their machine. And yeah, this all looks very harmful for now, but there can really be dangerous payloads for cross-site scripting. There's also a more rare variant. It's a DOM-based cross-site scripting vulnerability that only exists in the client-side code and is not necessarily reflective. It can also be stored in client-side cookies or anywhere else on the client. And it's a very interesting one because there are no good filters to stop them. And I'm going to look at the payloads. I'm missing out some of the content. I had some examples, but I will just type them later on. The different payloads, you have fake content. You could add a fake login form to a website that's vulnerable to cross-site scripting to lure visitors into logging into your fake login screen to steal their credentials. You can embed HTML objects like Flash objects or other objects. Remote JavaScripts can be used. You can execute scripts and plugins. It can be used for session hijacking. The session parameter is stored in the local cookies of the client. And because you're on the same domain when using the XSS attack vector, you have access to the cookies because you are from the same origin, so you're allowed access to the cookies. You could implement a proxy, generally loading the total content of the page into your own div and replacing all the HTML links with faked JavaScript. And so before you call the actual URL, you could send data to a malicious server by evoking an image on a strange server. And you also have some commercial web hacking toolkits that includes drive-by downloads using known vulnerabilities in browsers. And you could also add some more advanced JavaScript to the website, like maybe you've heard of the tool Jigto. That's a JavaScript bot that's been leaked a couple of years ago. Nowadays there are examples of JavaScript doing optical character recognition in the background, and there are examples of distributed botnets, and combining a distributed botnet with captcha cracking capabilities could do some severe damage. And also a good example of how a reflected cross-site scripting leak could be very harmful is by you could inject a flash object using the reflected cross-site scripting and use that flash object on a very busy site. And because the flash object comes from the same domain as the vulnerable site, you can use the XML HTTP requests to do requests in the background, and so misuse the dozens of users of the legitimate site that shows the banner to do some brute forcing attacks on the other side that holds the cross-site scripting. So you could let them try multiple passwords, try to log in, and so on. So it's not so harmless as most people would like to think, and therefore should not be ignored. Some tools that can be used for cross-site scripting are like tinyURL. It can be used when you have only little space to store your malicious script. Sometimes vulnerable parameters only allow short parameters, and therefore it would be hard to include remote JavaScript. And tinyURL could solve the problem. You have cross-site scripting post forwarders, so you can add a normal HTTP link to a website, and if people are clicking on the normal link, a redirector sends the right post parameters to the vulnerable sites to inject the malicious code. You have some proxy tool from OWASP. It's called WebScrap. It can be used to intercept the HTTP request just before it leaves your computer and goes to the web server. So you can alter all the content of the HTTP request. Then I use some different kinds of tools for Internet Explorer and Firefox. For Internet Explorer, I use WebScrap as a proxy to intercept the requests, and I use debug bar to get more insights in the current DOM of a page, of what's currently loaded in the DOM of a page. Let's see if we have Internet Explorer somewhere. I can show. Okay. I thought I had it on here. Oh yeah, it's here. It's just disabled. And it's a very easy to use tool. You can just take this and aim it at some object on the rendered web page to directly view the source on the left. So even for very complex and very big websites, it's very easy to locate a specific piece of source to see if something is wrong with the source. And yeah, it gives you insight into the runtime code that can differ from the one you've received from the web server by JavaScript doing a document print write, adding new code to the page. For Firefox, I prefer to use Firefox because of the temper data plugin that works pretty well. The WebScrap also works well, but it's a bit. But I'd rather use the temper data. I'm going to show you an example of temper data, how it can intercept the requests before they leave your computer. Tamper data is started, and you just click tamper data. And from that moment, every request that is made from the browser, you're able to tamper before it leaves your computer. So, when I press post, he will ask you, tamper with requests. Say OK, and you'll see a pop-up. It will show all the fields of the HTTP request itself, and you can adjust where needed, and also take a good look at this field that's called the host. In this case, I'm a very large banking site.com, and still affected. I'll try to do it again. And you can see you can adjust all the fields of the HTTP request to add malicious code or to check where things go wrong. And that's how tamper data can be used to manipulate normally hard to temper post parameters or some parameters that are sent in the background that are normally hard to tamper. And tamper data solves this problem. And in Firefox, I use the WebDev that does about the same as the debug bar. It gives you the ability to look at the runtime generated content that's stored in the document object model. Anti-XSS filters exist these days, and they can be implemented client-side or server-side or anywhere between. And EA8, for example, has implemented a reflected cross-site scripting filter that effectively stops very little reflected attacks, and it fails to block attacks from same origin. So if you are able to add an reflected cross-site scripting URL on the same domain, it isn't stopped by Internet Explorer 8. Flash-based redirects are also not filtered, or redirects from other plugins or other applications are also not blocked. And one big problem is that each perimeter is checked individually. So it will stop, for example, I will open up Internet Explorer to show what it will stop. If I add to this, I'll go to the search page again. Here we have it. Search for. We'll get the regular one. So we have the URL here. If I add a script tag here, I hope I'm using 8. What am I using? 6. Oh, it's a bad example, this. I do have the internet connected, don't I? Normally the debug bar also allows you to choose another rendering engine. Normally when used in Internet Explorer 8, it can be used to generate the content of Internet Explorer using old engines like the EA5, 6 or 7 engines to check if your website or cross-site scripting attack is also working on other versions of Internet Explorer. I'll check if we are connected at this moment. I will check later on. I will check later on for the examples that failed right now. I will go back to the presentation. But I can tell in what the problem could be. If you think about the search page, then Internet Explorer would block a request that has a very clear cross-site scripting in it, and therefore the attack will not be successful. But Internet Explorer fails to block a request like this, where the first script tag is split over 2 parameters, and therefore a successful cross-site scripting, reflected cross-site scripting can still be done in Internet Explorer with the XSS filter on. Okay. And so it effectively filters reflected cross-site scripting attacks in one parameter, but it fails to do if you split it over 2 parameters, and it also doesn't block injection of HTTP. So you can think of when you find to evade the Internet Explorer 8 cross-site scripting filter, you could inject an HTML link because that's pure HTML. It's not blocked by Internet Explorer. That includes malicious code in one of the parameters, and because the link is reflected in the page, and when it's clicked by the user, it comes from the same origin as the site. So it's as the first row says, requests from the same origin are not filtered. So you could always do a two-staged attack where you inject a link, and if the user clicks that link, it will successfully trigger the cross-site scripting attack, executing the JavaScript that's in the URL. Okay. Now, the way HTTP request query string that has more than one parameter with the same name is handled differs between the many different components that process the URLs. And for example, you can, this is always a nice one to check. These are all parameters with the same name, and different platforms like Java, JavaScript, or the PHP server-side code or the ASP server-side code would say that the val1 parameter is a different value than the other ones. And that could lead to strange situations and to filter evasion, as we will see later on. Like the latest ASP.NET has some anti-cross-site scripting filters in there, and they can very easily be evaded due to the strange fact that ASP.NET concatenates all the values of the parameters with the same name, separated by a comma. And so this query string will result in that value in, oh, here we have the, here we have a real live example. So here is the ASPX server, and I'm sending to it the parameters that are all named par1 in this example, par1, 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 and the server says to me the content of par1 is first, second, third. So you see it appends all the parameters with the same name. This gives us a good filter evasion possibility, because the ASP.NET XSS filters fail to filter multiple cross-site scripting spread over multiple parameters. So this works pretty well, and you also directly evade the Internet Explorer 8 cross-site scripting filters because of spreading the malicious script over more than one parameter. Another very common vulnerability on the internet, and much more dangerous than the cross-site scripting, is the SQL injection. While the cross-site scripting gives you the ability to execute code on the client side, SQL injection gives you the ability to execute code server side or even further in the back end, and could give you access directly to sensitive data as user details, login details, and other things that are stored on the data store. There are some simple forms of SQL injection. We're going to talk about some version detection techniques. I think the slide is missing out. But, SQL special variables, functions, and tables, blind SQL injection, filter evasion, column truncation, how to route a box, and some tools that can be used for doing SQL injection. SQL is used to communicate with database systems, like, for example, PostgreSQL, Microsoft SQL, Access, MySQL, or any other database system that uses structured query language or standardized query language. Web applications often use database systems to store their dynamic data, and therefore could be vulnerable to SQL injection. the web application generates SQL queries to select, insert, update, or delete data stored in the tables on the data store. And here is an image. So when a client sends an HTTP request for a product with the ID 12, the web server, the code running on the server is started, and it will produce the SQL query that it will then send to the database server. A database server looks up the SQL query in the database and then returns the result to the web server. There the server-side code uses the data to generate the HTTP response, so the client shows the page, is shown the page he requested. That's basically how SQL fits into web applications. And we have some simple injections, and that are still very commonly seen on the internet. And later on, I'll try to show you some more complex injections. Simple SQL injections is what we see here. With or 1 is 1. That is a very classical example that works very effective when login form, when user input in a login form is not checked for SQL injection. We have a union select attack that can be used to concatenate two search queries. And we have, in some database systems, we have the possibility to stack queries, so to enter more queries behind the current query. We have some interesting variables that could be addressed. See if I can get this example to work. I was trying to make it work. I have some product list that has some categories in it. Not sure it's going. And it will show the items of category 1. I'll show the info of this page. We'll see that this is what's loaded into the frame. It's items.php with a query string that holds the category ID, and the value of it is 1. And now if we want to exploit this, it's easier to open this one like this. And you see, it's not very interesting. I could check if it's vulnerable to SQL injection by adding an angle quote, a double quote, some slashes, and we will see it generates an SQL error, and it generates an SQL error because it's no longer a valid SQL query. And that's a strange thing. That means I have adjusted the SQL query that normally runs on the back end, and that is something that shouldn't be possible. So now I've adjusted it into a query that is broken, so it will generate an error. This error gives away a lot of information. It shows you the whole query, and even so now I see what's wrong with my query, and it enables me to adjust it into something that will create a proper SQL query again. So no error is returned. I did add or 1 is 1. The effect of that is that or 1 is 1 is true for every row in the table. So every row in the category table is returned here now, where if we only would have had the 1, it only returns the items from that category. I think, yeah, well, this is not very interesting that somebody can watch more items from the product list. And that's where we can use a union select attack to successfully do a union select attack. Two select queries can only be unioned if they both hold the same amount of columns in the result. And yeah, I don't know how many columns the result has, so I somehow have to figure out how many columns the first select query uses. I could have seen it before because of the SQL error generated, giving me too much information. So I can see, oh, I still don't know how many columns because it's a star, and I'm not aware of how many columns there are in the category. So I need to do some other trickery to find out how many columns we are. And the classical trick that I normally use is to order by, and then not by a column name, but by a column index. And for example, I try to order by column with index 10. That's a bad example, this. It doesn't seem to work on this particular web server I cannot make up the reason, but I will think up another way to figure out how many results there are in the first query. So we're going to union anyway, and just going to do so until we have found the right amount of columns. Dus now I'm going to union with 1, and he gives me no error. That makes me think the first search query only has 1 column. So if I try to join the first search query with a second search query that has 2 columns, in this case I have added 2 columns, it would give us an error again. I'm not sure what's going wrong here. What are you? Magic quotes or what? I cannot. Yeah, I've especially. I'm going to see if not necessarily, no. We could try. We try that. It doesn't seem to generate any errors anymore. Maybe we can try this one. Maybe it's better to show it here. Let's see if we can effectively manipulate the code so it works again and doesn't break. 5 minutes left, okay. So now I've made a query that works again, but no items are found. And I could try to figure out how many columns it has by ordering a column number. And now it gives me the result I was expecting all the time. Now we see here, because I tried to order on column with the index number 10, he says to me, you have an error in your syntax, and it's probably, oh, I forgot another quote. The examples are not a big success today, but I'm going to skip this one too. Okay. And when you successfully can do a union select attack, there are also some other tables you can join with, like the information scheme table that holds all the data about all the available tables and columns in a database, and so could point you to other interesting tables that you didn't know of. There are some cases in which SQL injection is possible, only you're not possible to output the query result into the response page, and you'll have to think of ways. I'm missing out a lot of. You have to think about ways of how to getting the query result out of the SQL server, and I've been using a couple of techniques to achieve this by doing database enumeration. A true SQL result will give no error, and a false SQL result often results in an error. And and you could use into out file to dump the result of a query into a file on the web server, and then by requesting it using your Internet Explorer, you could get your query data. Or you, in Microsoft service, you can open an inline connection, an ODBC connection to a second database to open a row set, or and in that way send out your data to another SQL server. And the last one is a very interesting technique. I won't have time much to show. Maybe something I want to say about filter evasion with SQL injection. In general, there are some classic examples of writing it quoteless by replacing or write it without white spaces, by replacing the white spaces with plus, or with a comment. This is a MySQL comment that can be inserted into the query to replace a white space. Or no white spaces. You could also, in some cases, you could also just use no white spaces, and it will also generate a valid SQL injection. If there's checked for if a value is numeric, you could use hex encoding to encode strings, and be careful that this not is the letter R, but it results in a decimal 144. And there are some filters that filter for SQL reserved words as select, and you could try to evade them by cutting up the select command. And then we have add slashes MySQL real escape and magic quotes. As of PHP 6, magic quotes will be removed due to the lot of problems it has generated in the past, and it also fails to sanitize data that comes in other ways than post and get variables. So it fails to sanitize script names. It fails to sanitize server variable like the host or the user agent, and only in the later PHP versions there is a possibility to enable magic quotes to also magic quote real-time results of SQL queries or the result of a command executed in the shell. I think my time is about up, so I'm gonna. We're going to skip to the end. Yeah? Yeah. Maybe too much. And yeah, and of course, I'll advise you to all check the web applications around you that you own if they have any security leaks. So. We can improve the safety and security of the internet together. And I advise you not to try these things at servers you do not own. And also be careful trying this on networks you don't own, because a wrong query could easily overload the network, or could easily overload a shared hosting server. So be very careful when trying this on in real life.
So I think we've got time for at least one or two questions, even though we've gone over a little bit. So if anyone has any questions or would like to see a demonstration, do put your hand in the air and ask away. No? Come on. Or you're just dying to get dinner? Yeah, okay. All right, I think we can release you all to go get something to eat and get fearfully stoned or drunk or something.
Yeah.
Oh, don't worry. It's okay. It's okay. You know, pretty good. If only the demonstration was maybe the server was a bit more rehearsed or something.
Yeah, I'm not sure what's going on.
So, thank you very much. And can we have a big applause, please, for Jaco? The next talk in this track will be Dan Kaminsky's undisclosed topic, which usually can be summed up in 2 sentences. The internet is fucked. So we will see you all back here for 8 o'clock.